Alright, so I think this is recording. We're looking at skill packet 7, the review problems from our skill packet 7. And here in problem 23, they give me the sector, they give me the radius and the arc length, and they want me to determine the angle measure and to give that angle measure in both radian measure and degree measure. So I know that the arc length is equal to r times theta when theta is in radians, and theta is my central angle here. So I know that if I divide both sides by r, if I take the arc length divided by r, this will give me the angle measure in radian measure. So 6 divided by 5, and so in radian measure 6/5. We don't have to put, we definitely don't want to put our degree symbol there. If you want to put radians here, I mean, you can, but without it, it's implied anyway. So I usually just don't write it. For the degree measure, I want to take this 6/5 and multiply it by my conversion factor. The thing is, do I want 180 on top or 180 on bottom? Since I want my final answer to be in degrees, I want the 180 degrees to be in the numerator, and I want the pi to be in the denominator. So this time I am going to use the scientific calculator and round this to, I think my calculator right now is fixed to 1 decimal. So let's check. Yeah, and 1 decimal is fine. The numerator is 6 times 180. And the denominator, I'll put parentheses around 5 times pi. So to 1 decimal point, I'm getting 68.8 degrees for this central angle right there. So in radian measure, 6/5. In degree measure, approximately 68.8 degrees. Alright, so let's take a look at this next one. So what we're calculating is this angle, theta. And since the arc length is equal to r times theta, theta is equal to the arc length divided by the radius, and that's going to give me the angle measure in radians. So this arc length is given as 10.6. The radius is given as 2. Now, make sure that those both have the same units, but I'm not going to give you ones that would not. But if it was some application problem or some in the future, somebody giving you this, one way that they could make it more difficult to see if people are paying attention is to give the arc length in one unit and the radius in a different unit, like to give this in centimeters and something else in decameter, like meters. So anyway, half of 10.6 is 5.3. So my radian measure is 5.3. So let's take this radian measure and let's convert it to degrees. So when I multiply this by I think of it as multiplying by the number 1, where the numerator and denominator are equivalent to each other. I want the degrees to be my final answer, so I want 180 degrees in the numerator. And this radians that's in this numerator, I want it to cancel with the radians that's in the denominator. So if I take 5.3 times 180 divided by pi, this will give me an approximation to 1 decimal. 303 point, So there's no indication that they had drawn this to scale, but if it is to scale or roughly to scale, 303 makes sense with that picture, that 360 would be a complete circle and 303 is getting real close to completing a circle. Kind of looks like a Pac-Man, doesn't it? Alright, yeah, let's change that to, yeah, what, do I have a paint? I think it'll just do the whole thing. Oh, no, yeah, it does the whole thing. Alright, anyway. So I'll do this in the next video.